So my presentation today, I want to touch base on something I think very critical, and it's called foundational technologies, right? And I strongly believe that machine learning and artificial intelligence falls into the same category as of foundational technologies, right? So by definition, a foundational technology is one that enables the applicability of that technology across multiple different applications, multiple different domains, right? So something that can solve a variety of problems and potentially disrupt multiple different industries. So let's look at a few of these innovations. These are the top 10 innovations defined by the US Librarian of Congress as history's most important innovations, right? If you look at this list, these are all what I would consider foundational technologies. Number one, printing press. Light bulb, aeroplane. And again, if you dwell a little more into each of these, you will realize that it has really been applied across multiple industries, and as a result, disrupted and innovated those industries, right? So for example, with the advent of the printing press, we saw a lot of knowledge sharing that happened. Whether it was news or whether it was knowledge in paper in terms of schools and so on, right? So a lot of knowledge, a lot of data sharing and so on. Light bulb, all of you all know the lights. Aeroplanes, long distance travel by aeroplanes, personal computers, you all are all aware of. In healthcare, vaccinations made significant progress in healthcare. Automobiles, timekeeping using a clock, telephone, storage of food using refrigerators, and the camera, right? So these have been listed as the 10 most important innovations, and they are prime examples of foundational technologies. More recently, listed here are a few examples of more recent foundational technologies, right? The internet is definitely a foundational technology that has disrupted and built many industries around it. The smartphone is another example. So for example, on the internet, if we didn't have internet, we won't have Facebook, Google, and all these amazing apps like Airbnb and so on. The same with the smartphone and personal computers, right? Definitely foundational technologies. So I have listed here my personal opinion and not necessarily anything that based on what I read and my opinion, 4 foundational technologies that are in early stages, early to mid stages today, right? And I feel machine learning and artificial intelligence is one of those things. Something that will be applied across every single industry and across every single domain. Renewable energy and solar is another very important innovation that's continued to disrupt that industry. 3D printing, very early stages, and then all of you all have heard the early stage happenings of the autonomous vehicle, the driverless car, right? So typically, if you look at the characteristics of foundational technologies, the technology has really adapted and grown typically over 50 to 100 years, right? It takes about 50 to 100 years for each of these technologies to have adapted and grown. But if you see what's happening now with the advent of internet tech and the access to computing, cheap access to computing and mobile phones and so on, you're seeing this happening typically every 10 years. So every decade there are new foundational technologies that are coming up, right? And if you look at the characteristics a little more, they typically start very small, with very small adoption, right? So if you look at the internet, back in around 1996, when I first started coding, the internet was in its very, very primitive stages. We, in fact, built products and solutions that were using the internet, and every time we used to go out to customers, they would say, no, this is not going to work. This is really not applicable to us, right? But see what happened, right? There's typically a catalyst that comes in and makes that technology really take off, right? So if you look at the example of the internet, the biggest catalyst was low-cost data. By around 2000, you saw data being much more affordable, and you also saw personal computers becoming more affordable for people, right? Around that time, because of these two catalysts, the internet really took off, right? And now, as you know, the internet is across everyone. You can analyze that in the same light of machine learning and AI, right? So machine learning has been there for a long time. In fact, when I was a student, we used to study machine learning and some very early concepts like neural networks and so on. But what has happened in the recent past that has been the catalyst that has really taken this over is, number one, low-cost storage. To build your data models and play around with your data, you need a lot of low-cost storage, which was very expensive. Low-cost fast storage, right, which was very expensive and slow before. And finally, one of the most important ingredients for this catalyst is the fact that it is the amount of machine power that you need, right? Processing power for all algorithms and so on. So these are the two things that I personally believe are the main catalysts that are driving the adoption of machine learning and AI to be a foundational technology that will be applied across the board. So very similar in terms of how the internet started and how it got adapted and grew, and now what you're seeing happening with machine learning. So I said a foundational technology needs to be applicable across multiple different industries, and I want to show you two examples to show two very different industries in a wide spectrum of the usage of machine learning, right? This first project is a project called Project Maven, a very interesting project done by the US Defense. I'm sure some of you all may have heard about this project. There has been some controversy about it as well, but very interesting and amazing way they are using it, the technology, machine learning and AI, right?
The military is using Project Maven to hunt insurgents. The technology is helping human intelligence analysts identify objects on video feeds from drones that are high up above the battlefield.
Yeah, southeast.
You know, it's kind of like a Facebook photo in how it learns. When you upload a photo into Facebook, Facebook will be able to identify which of your friends are in that photo. And if it doesn't know which one of your friends is in that photo, you can tell it who it is, and then it'll know in all future photos. Project Maven does the same thing. It'll identify a car or a building and put a box around it just like that Facebook photo and suggest what it is to the analyst. Now, if it gets it right, the analyst clicks, yes, it's right. But if it gets it wrong, the analyst will correct it. And thus it learns. You know, in the past, a human would actually have to be sitting at a computer and tag individual objects that he or she sees on the screen. Stuff like people, vehicles, or even structures and houses. Now the algorithms will actually give suggestions of what it thinks those objects are. This collaboration between the analyst and the computer is what has become known within the Pentagon these days as human-machine teaming, and it's become a really high priority to use this type of technology and teaming in all sorts of future weapons that the Pentagon's developing. So the technology is being used primarily in the Middle East region. It was first deployed with special forces, but the idea is to actually broaden who has access to it in the coming year. While it was first only available on small ScanEagle drones, the idea is to move to larger, higher-flying drones like Reapers and Global Hawks, which also happen to have higher resolution cameras. So military officials say Project Maven is doing really well, and it actually gets better as you use it. In its first week of deployment, its accuracy went from 60% to 80%. So you could say it's learning on the job.
Very simple, right? You're looking at visual. Typically, a person would be looking at that visual over and over to identify an object that is a potential threat. And that information is with that individual, where they're adapting machine learning to actually study an area or a pattern and then give the analysts feedback about what that object could be. So that was an example of a very high-end defense, very in-depth technology adoption of machine learning. I may not play this video in full, but here's
Hi Kickstarter, my name is Luke, and I'm the co-founder of Colibri, the world's first connected electric toothbrush.
Colibri collects data about your brushing habits and transfers it to any iOS or Android device.
telling you how often you brush, how long you brush, and what areas of your mouth need more attention. The whole idea of an intelligent toothbrush that gives us feedback came to us after realizing we actually have no idea of how effectively we brush our teeth. Most of the time, we do it quickly, mechanically, without paying attention to what we're doing. And for kids, it's definitely not fun. That's why we decided to put together an amazing team of engineers, designers, programmers to change the way we use our toothbrush and help improve oral hygiene along the way.
When the Colibri team first came to us for input, we were impressed on how they're right on target. 90% of our patients don't brush well.
The toothbrush is equipped with motion and directional electronic sensors that are able to track duration, frequency, and neglected zones. Thanks to its Bluetooth chip, the toothbrush then sends the information gathered to the mobile app. In addition to the real-time experience, we designed a series of user-friendly reports that chart your daily and weekly brushing performance and help you set new goals. Or you can then decide to share your stats with your dentist, with whom you can interact directly through the application.
It's great for us to be able to transform our dialogue and give feedback to our patients outside of the dental office. I'm not only a dentist, but I'm also a mom. As a mom, it's almost impossible to follow your children constantly over their shoulder.
Children's brushing performance can easily be monitored and shared through the app's graphics, fun games, friendly competitions, and symbolic prizes. And you'll be able to have the entire family's brushing habits in one single device. Because we want Colibri to be part of a growing interactive experience, we provide open APIs to allow developers to create mobile apps from the data gathered by Colibri. Well-being apps, programs for dentists.
So I wanted to show that as a very simple example that everybody here brushes their teeth, I'm assuming, that that can be applicable for us, right? And that company is a company based out of Paris, and now they're using much more machine learning to be able to predict patterns, dental problems, and so on, right? So again, the reason I've showed those two diverse examples is for you all to understand the application of a foundational technology is going to happen across the board, right? And I'm not going to go through all of these slides, but you know about the driverless car, the machine learning happening there. Healthcare is another massive industry for machine learning and artificial intelligence, and that list goes on, right? This is another very important statement that I think you all need to understand, is that what we are seeing today is at best teenage years of a being with an infinite life, right? So let me explain briefly what that means. So typically, even if let's say you're a doctor, and let's say your life expectancy is about 80 years, you have experiences and learnings and stuff like that that you contain and that are useful for you when you perform an operation. And then once you're no more, in best case, you would either built an understudy or you documented all your research, right? But those experiences are something that's very difficult for you to give to someone else, because there's a lot of stuff that doctors and so on use through experience. Here, the biggest advantage that artificial intelligence has is that it's an infinite life. Unless you pull the plug, that unit does not die, and those experiences continue to build over and over the multiple years, right? So significant amount of learnings that can be built into that. And another very important thing is typically a doctor may be constrained towards his experiences plus maybe 10, 15 others and what he reads. Whereas in artificial intelligence, if you apply that, the AI will learn from thousands of other units out there, right? So just my last slide. I also feel very strongly about the technology stack of the future. All of you all know that this is the typical technology stack. You'll have a front-end application, you have your middle tier business layer, and then your data. But I can guarantee you in the future, machine learning and artificial intelligence is going to be standard. That you're going to use this and apply this across every application that you build. So in the past, you would store your data more in terms of how you want to present it or to be able to retrieve and show it. But now and even in the future, you want to have to store your data such that it can be read and mined intelligently, right? So this is something I strongly believe in. So in summary, in my opinion, machine learning and AI are foundational technologies. What you're seeing here are very early stages of a technology that's going to continue to disrupt multiple different industries and are going to be foundations right across.